Alright. So the original problem was secant minus cosine. So what's secant? Yeah, so secant is 1 over cosine. And now I am going to subtract these, so I'm going to get a common denominator. So this one needs to have a cosine. So now my denominator is cosine, and my numerator is 1 minus cosine squared. Now this should cause you to like, oh yeah, I've seen that before. What's 1 minus cosine squared? Sine squared. So now we have sine squared over cosine. Now this is where we need to leave the directions. Rewrite, where am I? A product involving tangent and sine only. Okay, so keep in mind that tangent is sine over cosine. And then I have another sine on top. So if I split this apart, would you agree that's the same thing? But now I have tangent times sine, which is what they wanted. Okay, we all good there? All right, let's get out our multiple choice, number 1, test number 1, multiple choice. Practice exam 1. So part A, 28 questions, no calculator, and you get an hour and 20 minutes. Okay, so keep that in the back of your mind as you're going through and practicing these problems. Think about how long it's taking you to do it. You have an hour and 20 minutes to do those 28 problems. I think you can do it. But let's see. Multiple choice, here we go. The polynomial is given by this equation. Am I on the right test? All right. What are all the intervals on which the polynomial is greater than or equal to 0? Well guys, this isn't bad. What does that mean? If I'm going to be greater than or equal to 0, that means I'm above the x-axis. So what intervals are above the x-axis? Oh, well, I guess I better think about what it looks like when I graph it. This is a cubic polynomial. It has zeros at 0, 4, and -2. It's cubic, right? And it's negative. So how does a negative cube behave? Xander?
Does it start from the top?
Yep.
And then they go through all of them and then end at the bottom?
Yep. Now, no bouncing, right?
Yeah.
They're just straight zeros. We're just zipping right through. So where am I above the x-axis? I'm above the x-axis from negative infinity to -2. Would you agree with that? And then I'm above the x-axis again from 0 to 4. So I think the answer is D. Now, there's another way you could do that. You could do this with a sign chart. You have your 3 factors, right? And you need that product to be positive. So you could certainly do that also on the number 1 with the sign chart. Anybody have a question about that? All right, we have f of x equals 9 times 25 5 to the x, and we need to rewrite it somehow. Well, what do we know about 25?
It's 5
5 squared. So we could, one option would be 9 times 5 to the 2x.
Like that.
Is that option there by any chance? It sure is, so that's it. Now, we could also have rewritten the 9 as 3 squared. I didn't see a 3 squared on there, so that's why I didn't go that way. All right, number 3, oh my gosh, I remember August, this gave us fits. I think we can do it now. Look at number 3, tell me what you think. Read it carefully, make sure you're answering the question that's being asked. A, absolutely. Those used to be so hard, but I think you guys have mastered that now. The curve is increasing and concave down on the interval from A to B. All right, number 4. Which of the following describes the end behavior of the function? Okay, tell me about this function. It is a 6th degree. That is even. It has a positive leading coefficient. So it is up, up. Whatever's going on in the middle there, who cares? It's up, up on the ends. So what's my end behavior? The limit as x approaches infinity of my function is what? Infinity. And the limit as x approaches negative infinity is infinity. This is so cool, we know what we're doing. All right, let x and y be positive constants. Which of the following is equivalent to 2 ln x minus 3 ln y? PEMDAS, take care of those exponents first. Aren't these exponents here? So this is ln x squared minus ln y cubed. And then the minus tells me I'm going to divide. So A.
It's good to be.
It's good for you, it's good for me, Oscar. Okay, number 6. The polynomial function, okay, which of the following describes the zeros? Might be a good idea to go ahead and factor that second part of the problem. So our polynomial is x plus 3, and then x minus 5 plus 3. So what do we notice? We have a root, that's not a hole. How do we get holes? Cancel, right? Can't cancel on a polynomial. Okay, we have a double root. We have a root that has multiplicity 2, which means if I graphed it, it would bounce at that point. But that isn't the question. The question is, how many x-intercepts does this problem have? 2. Now, technically, there are 3 zeros, but 2 of them are the same point, so there's only 2 distinct zeros. So A is your answer. All right, number 7. Now we got something that could have holes. But the question is, it has a vertical asymptote at x equals negative 5. What does that mean about your function? If it has a vertical asymptote, don't you have to have an x plus 5 in the denominator? And furthermore, that x plus 5 has to stay there. It can't cancel out, because if it canceled out, it would be old, not an asymptote. So which problem has an x plus 5 in the denominator that's gonna stay there? D. The answer's D. Does that make sense to everybody? All right, now we got a sinusoidal function. What's the period of this thing? Oh my gosh, if you miss this, I'll hunt you down.
It's gotta be this question, right?
What's the period? 4. 4. So the answer's C. 4. You don't think it's 4? Oscar, you good? Okay. All right, number 9. Which of the following is the transformed graph? All right? What has changed? When we do f of x plus 1 minus 2, how are we moving our picture? Left 1, down 2. So you want to find the option that is the original picture, left 1 and down 2. Anybody see it? A. A. This means left 1, this means down 2. Number 10 already. Here we go. The exponential function table gives us which of the statements is true. Now remember, this is no calculator. So if you think, oh, I'll just do a regression, no, this is no calculator. So we got to figure out what's going on here. A times b to the x. Well, what does A stand for, you guys? In any exponential, what does that A stand for? The initial value. It is the value that if you put 0 in for x, don't you get just A? So what is our A? If you put in 0 for x, you get 3/4. Now, what am I multiplying by to get from 3/4 to 3/2? Or from 3/2 to 3, or from 3 to 6, or 6 to 12. What am I multiplying by? 2? Isn't this my equation? So what have I got? Definitely growth. And A is positive, and B is bigger than 1, so I think it's D. Do you remember that whole deal where if this is a number less than 1, you're decreasing? Decay? Alright, so function f, I'm looking at 11. Which of the following is an expression for f of g of x? What's g? So what does f of g of x mean? We're plugging in g into f. So let's see, that doesn't match anything. There we go. See? All right, a couple more together, then I'll say loose on your own. Number 12. following claim and exclamation statements best fits the data. So this is multiple choice, but you kind of have to know what's going on because you have to make a explanation. So what are you thinking? What are you doing right now while I'm up there copying and calling down? What are you thinking about? Xander?
When I looked, and I just like found the difference between the
Yep.
just like carry on
So this one is
25,
25,
19,
19,
and 7.
what's this one, 13, and 7? So, number one, it's not linear, because what happens if it's linear? They're all the same. These would all match. The average rate of change would be the same. These are all the same size here. So we can just look over here. All right, well, how about second differences? The second differences are all -6. What does it mean when the second differences are the same? It's quadratic. So we have to find one that says quadratic. Okay, so it's either C or D. The rate of change over consecutive equal length input, no, that's C isn't right. The change in the average rates of change is constant. This is the change in the rates of change, and that is constant. So the answer is D. All right, one more, number 13. Seven sine 2x, which is an equivalent form of that. What are you thinking? What's going through your mind right now? Sine 2x is?
Sine x times. Isn't it
Sine
sine
2x, gotta know. Sine 2x is 2 sine cosine. So, which one matches? A. Alright, so now what I want you to do is, let's see how far you can get. We're gonna touch base. Try to get at least a 28. Okay, so go with your partner, by yourself, whatever works for you.